Welcome to Lesson 5, For Loop, Topic 1. If you've ever experienced having to turn on all the NeoPixels, you'll realize that there's a lot of copy and pasting there, and simply changing of the positions. Well, anytime you find yourself in a program doing a lot of copy and pasting, this is a clear indication that possibly your process could use a for loop. That's what a for loop does. For loop is a new concept that will allow the program to repeat commands. So in this video, we're going to cover the purpose, the syntax, and a quick application of turning on all the NeoPixels. So let's get to it. So as mentioned earlier in the video, again, if you were challenged to turn on all the NeoPixels, you might have done something like this, where you wrote the first line, copied and pasted it 9 more times, and then simply changed the positions. And now let's say a different section of your program changed the NeoPixels from red to green. So you might find yourself copy and pasting this, making all these 255s to 0, and then changing all these zeros to 255. Again, rather annoying. And let's say there was yet another section of your program that now changed the NeoPixels to blue. So you would copy this yet again, and then change all of these 255s to zeros, and then change all of these to blue. And let's just say, for the sake of argument, you had another section that changed them all to white. So now you have to copy this yet again. So hopefully you could feel the frustration. It's not what you want to do. It is a lot of wasted work. Here to save us is a concept called the for loop. So in the first half of this video, we're simply going to discuss the syntax of it and then explore an application. Hopefully you'll see the motivation and the strength of using a for loop. So much like an if statement, you're going to write the word for, then you're going to write parentheses. And inside the parentheses, you're going to specify some information that the for loop uses. Just as a comparison, an if statement required a condition in order to complete its process. Well, for loop's a little more complicated. It actually has 3 parts, and we're going to review them as we go. So here's part 1, and hopefully you'll be able to kind of let me know what this is doing. Again, we've seen this before. Int I equals 0. Well, it looks like it's creating a variable, and that's exactly what the first part is doing. I'm going to call this variable a little bit different. I'm going to call this the loop variable, because this variable only exists right here for the for loop. It's kind of an internal variable just for the for loop. And we're going to assign it an initial value. All right, cool. Let's go on to the next part. Now you'll notice that I terminated the first part with a semicolon. Again, that's something also you're comfortable with when you created loops up here. The next part is something you just recently learned about. I less than 10. We saw this in if statements. The second part is a condition to be met in order to repeat the process. So as long as the condition is being met, we're going to repeat the process. So right now, if I starts at 0 and we're checking to see that I is less than 10, well, it happens to be that it is. So we're going to do the loop. Now, this is a loop, so it's going to keep repeating as long as this condition is met. Now, think about it. We start at 0. Is 0 less than 10? It is. Is 0 less than 10? It is. Is 0 less than 10? It is. So what I'm trying to get at is, we need to do something to modify that loop variable, or else we're going to enter into something called an infinite loop. Being that the I variable, if it starts at 0 and never changes, it's always going to be less than 10. Which brings us to the third part. We have to modify the loop variable in some way. And probably the easiest way for us to do is to do I++. Simply increase I by 1. So if we start at 0 and we slowly, as we repeat this process, we slowly increase I by 1, then eventually we will get to a value that's bigger than 10. All right, so let's go ahead and do a little serial monitor here, serial print. And let's print out the value of I. Let's give ourselves a little space between the numbers. And then let's also give us a little separation after we get out of the loop. Of the loop. Oops, already got that. All right, let's see it. Oops, let me put a delay here or else it's going to go way too fast for us to see. It's going to be instantaneous, so let me upload that again. And now, because I want you to see how the I variable is changing while we're in the loop. And let me clear this out. All right, so you can see here our first value of I is 0, and it's slowly increasing as we go, all the way up until 9. Then we're out of the loop, which means we're here, we go up to the top, and then we repeat the process again. So notice, you were already accustomed to this idea of a loop because our void loop is a function, but it's a function that gets repeated as part of the Circuit Playground Express. So our for loop is doing something similar, except that it does it within the function loop. So let's look at the numbers again. So we start at 0, and notice that we end at 9. We end at 9 because we're looking for the last value that's less than 10. Well, that happens to be 9, because when I becomes 10, is 10 less than 10? It's not. 10 is equal to 10. So again, and we're going to explore some other examples that will help us practice the individual sections. The last thing I want to point out, notice how the numbers increase by 1. Well, that's this I++. Right, so those are the 3 parts of a for loop. Let's start changing them around just to explore how we can control what we do. So the first thing is I'm simply going to change this from 5 to, let's say, 11, and we'll leave this last part alone. And I'm also going to put an equal sign here. So we're telling the for loop to start at 5. We're telling it to continue as long as I is less than or equal to 11. So I want you to think about what's going to happen with this 11. Is it going to get printed out, or is 10 going to be printed out as the last example? So we start at 5, we're increasing by 1, but remember this is a condition, just like an if statement. So it happens to be that when I becomes 11, well, 11 is less than or equal to 11. So it actually includes the 11 in the output. So it's going to be your job, your choice to decide, well, how do you want to write your if statements? Some people, if they wanted the 11, they would do this, because this would also work. Just to show you that it does. Let's clear out the output. So see, we start at 5, we're increasing by 1, and we're going to get to the 11 because 11 becomes the last number that is less than 12. So it's really your choice as to whether you want to do a less than or equal to at this point, and then choosing the appropriate kind of final value for the for loop. In all these examples we've done so far, we're increasing by 1. Well, we can do more than that. So let's go here and let's change this from the plus plus to the plus equals, which, if you remember, that's a shorthand operation for modifying a variable by some value. And this time what we're going to do is we're going to do a plus equals of 2. And I'm going to go back to our original for loop of starting at 0, going to 10. The difference here now is that, again, we're increasing by 2. So we still got the 0, but notice the next number. It's 2, 4, 6, 8. We don't get the 10 because, again, once you get to 10, 10 is not less than 10. All right, so this might be a convenient way of maybe turning on all the even neopixels. But what if we wanted some odd numbers? How would we change that? Well, you might realize it's not that much different than the even number. The only thing that has to change is where we start. So if we start with 1 and increase by 2, well, what kind of numbers do we get? So here's 1, 3, 5. So notice the plus 2 is still the right solution because we want to increase by 2. The only thing that changed here was where we wanted to start. So here are the odd numbers. All right, the last example I want to show you is a way to kind of go backwards. Because notice, in all the examples we've done now, we started at some low number and increased to some high number. Well, there might be instances where we want to go the opposite way. So let's start, let's say, at a high number. Now, if we start here, again, this second part is a condition that we want to meet in order to repeat the process. So because we're going backwards, we kind of want to say that as long as I is bigger than some value, let's say bigger than 0. And at this point, I am going to put the equal sign here because I actually want to get 0. I want to get to 0. So right now, is 10 greater than or equal to 0? It is. Now here's a common mistake that some beginner programmers do. They'll leave this section alone, and I'm going to go back to my plus plus. Right. Now if I increase by 1 each time, that means this number is going to get bigger. And look at our condition. Our condition is simply checking to see that a number is bigger than 0. And if we keep increasing this number, it's always going to be bigger than 0. This is also an infinite loop. So again, you got to watch those things. You know, look at your start condition, look at your starting value, look at your condition, and make sure that at some point your condition is no longer going to be met, so you can get out of the loop. So in this case, if we want to go backwards, what we want to do is we want to decrease the value of I by 1, so that eventually this becomes a negative number. Because once you get to a negative number such as -1, is -1 greater than or equal to 0? It's not, which means the condition will no longer be met and we get out of the loop. Let's explore this one. So in here we start at 10, then we go to 9, 8, 7. So we're decreasing by 1 because of that third part. We're telling it, take 1 away from I each time. You'll also notice that we get to the 0. So that we can actually get the number 0, we put the equal sign here. All right, so hopefully now you have a little appreciation as to how the for loop works in terms of the different parts. But now let's see a practical application of this. So I'm going to go back to my original for loop, which had us do this, and I'm going to leave the delay in there. I guess I can leave all that in there. And now let's add the serial playground.setPixelColor. And let's just put our basic one. Now, if I ran the program like this, we already know that this is going to run 10 times. But it's only doing the first neopixel. Again, that's not going to be very useful. We can do that with one statement. There's no need to keep resetting the first neopixel to red. What we want to be able to do is to somehow change the 0 neopixel, the 1, the 2, the 3, the 4, the 5. And hopefully you can kind of see the connection now with the for loop. In our for loop, what is starting at 0, slowly increasing by 1 all the way till it gets to 9. Oh, that's this loop variable. I can put this variable right in here and it will allow me to actually turn on all the NeoPixels. And let me throw in a Circuit Playground clear pixel. Oops, clear pixel, not set pixel. And let me turn on my camera. I realized I don't have it on. Okay, there we go. And let's run it. Oops. I spelled Circuit Playground wrong. It happens to the best of us. Alright, so let me pull up the serial monitor, let me clear that, let me pull up the camera, and now we kind of see all three things happen at the same time. Alright, so I want you to make the connection between the numbers here, and notice how it's slowly turning on all the NeoPixels. And then we're out of the loop, we repeat the whole process again, which means we clear the NeoPixels. Now we enter the for loop again, and notice it's 0, 1, 2, 3. Those are the numbers being produced by the for loop. But I want you to make the connection. This set pixel color is one command that's being repeated over and over again, and we're using that value of the loop variable as part of our position. Now obviously we can have a little more fun with this by reducing the delay. So let me do that. But then let me also put in here, what if we wanted to only do the even numbers? The even NeoPixels. So we could do the plus equals. We already saw that. That's going to give us the 0, the 2, the 4, the 6, the 8. But now we're using that in conjunction with the NeoPixels. Let's put this here. Let's bring up the camera. And there you go. Notice, it's only the even ones. And then we repeat the process again. Again, I can't reinforce it enough. Make the connection between the loop variable and the values of that loop variable and how we can use them as part of some other command, such as the set pixel color. Now, what if we wanted to color all the green NeoPixels? I mean, all the odd NeoPixels green. Well, we've seen that example already. So let's do that one real quick. And I'm going to take out some of the fluff in here. Actually, no, let me leave it in so you can actually see it. Because I don't want you to think that the for loop typically has so many things. There's no need for these serial prints or the delay in here. I'm simply doing this so we can discuss it as it's going. So notice, if I wanted to change them all to green, I just have to change the one command and run the for loop. Let's upload it again. Look at our serial monitor. Pull up our camera. Clear this. So here we go. This is the first loop that's going 0, 2, 4, 6, and then you kind of see the second loop now does the even one. So I'm going to do it this way. So that's the first loop. Here's the second loop. So again, a lot of interesting effects you can have by using a for loop. And notice there's easy modifications. So now let's say I didn't want red. Let's say I wanted magenta. So I can do 255 here for red and blue. And let's say that instead of green, I want it yellow. I changed it. So I made two changes, and now I could change the whole color pattern of this. And let me demonstrate that one last time. And then we should be good to kind of conclude the video. Just as a motivation that now that we've done this with a loop, makes it a lot easier for us to modify the outcome. All right, so let's go back to our presentation. So in this video, we introduced the for loop, which is a concept that allows us to repeat instructions. It has three distinct parts, which is the loop variable, the condition, and then the modification of that loop variable. By using that loop variable, we can now control different aspects of our Circuit Playground Express, in addition to just doing other types of calculations. So hopefully you're excited that you don't have to repeat instructions anymore, and enjoy.